We're on ITV, bringing us to the first discussion segment for the day, and it is, as usual, the aviation. Of course, I have with me the aviation freak, who also doubles as an estate surveyor and valuer, Mr. Goddy Ike. He has gone far and wide when it comes to the issue of aviation in many parts of the world. Okay, and I must say a very good morning to you and welcome to the program.
Good morning, Joe.
Yes, at the weekend, I know you saw that Paris, China flight that injured about 26 people.
Yes.
Due to turbulence. And it's one of the topics we treated
last week.
Some time ago. Yeah, last week or so. Yeah, when we talked about clear air turbulence. So what's your take on how that happened and people that were injured?
Well, Joe, the issue of turbulence remains a question of different winds moving at different speeds and from different directions meeting and then creating a chaotic situation. For instance, if one is coming from the west and moving smoothly in his, or rather on his path, and this other one is coming from the east at a different, speed, maybe faster than the other from the east, and another one is coming from the west, then as they meet, they create a kind of a chaotic situation which would create some undulations and make everywhere really rough. And the thing is, you don't even see them through the cloud. It's invisible. And more often than not, onboard radar equipment in the aircraft won't even notice them. And then the pilot suddenly gets into them, and then this is what you just find. All sorts. And
now getting out of such turbulence, on hot, or getting out of such turbulence without causing some level of fatality, do we need special training for pilots?
Oh yeah.
To be able to maneuver when it comes to
definitely. Pilots, it's one of the major courses that they do in the aviation schools. They are taught about how to avoid turbulence, especially the one that is known as microburst. As a matter of fact, that is the real killer, and that is the one that actually causes most 99% of the accidents associated with wind shear and turbulence. And I'm going to show you what microburst is all about, and then demonstrate with our miniature here what happens and why pilots usually fall prey to microburst. Get me the photograph microburst 1. Can you get me on screen photograph microburst 1 so that my viewers will, that's it, Joe. It's a keep it on the screen while I explain this phenomenon to my viewers. Take a look at that vertical push down all the way from the skies. It happens more often than not during thunderstorm. Joe, can you see that aircraft approaching for landing to the left of the photograph? Yeah. All right. As this three-dimensional microburst comes down, it's said to be three-dimensional because as it comes down vertically, that's one dimension. It hits the ground and spread out, one to the right and one to the left, and those spread outs are known as outflows. That's what they are called, the outflows. All right. As the plane unsuspecting, aircraft, unsuspecting pilot, comes in. He notices that he has a headwind. That is the outflow to the left of this photograph.
Yes,
we give that aircraft that is approaching a headwind, tip up the nose of the aircraft and increase the airspeed. And the pilot, who hadn't been informed that he's been up against microburst, who's approaching at a particular set speed, say about 150 or 160 knots, when the aircraft is very vulnerable and slow, waiting to touch down nicely at the appropriate speed. Now he suddenly finds that his airplane is gaining airspeed beyond what is required for touchdown. The pilot naturally pulls back on his throttle stick to reduce power on the engine and slow down the aircraft. Now what happens? Quickly, the airplane transits from that headwind that he's experiencing from the outflow to the left, and then come right underneath the vertical push. And as that is pushing, he begins to notice, the pilot begins to notice a quick sink, on the landing aircraft. He finds out that he's falling below his glide slope. Remember the instrument landing system that I taught you, where you have to stay on the glide that will terminate you at the threshold of the runway. Now you suddenly find yourself below the glide slope, showing you that you are dropping vertically more than required. And then, of course, the struggle will be to pull up, to put some power, to really, and then the killer one now comes as a pilot suddenly notices that he's coming down vertically faster than necessary. He quickly pushes forward on his throttle stick to gain power. Remember what I taught you during the jet engine? Do you remember how many seconds I told you that a jet engine would require to respond to power demand? Do you remember? I taught you that during the jet engine, when we did that about jet engine. Now, an average jet engine takes at least 6 seconds to respond to power demand. As you push on your throttle, forward to ask for power, it takes 1, 2, 3, 4, 5, 6 before you get the blast from those engines. Joe, in that kind of situation, those 6 seconds are as long as 6 light years. They're too long for the pilot to control the situation. Now, what happens next? Now that the camera is on us, I'll use this miniature to show my viewers, how deadly microburst that creates the wind shear, the killer wind shear, takes place. This man is coming nicely at set speed with all the flaps deployed, for the wind direction that he'd been informed,
and of course,
the speed.
And of course, using ceteris paribus, all things being equal.
All things being equal,
of course, envisage.
And then as he's coming, suddenly he finds that a strong headwind is right opposite him. Now what happens is that headwind tips up the nose of the aircraft, and airspeed increases. And then the pilot quickly, knowing fully well that he's exceeding the airspeed required for the touchdown that he was heading to, quickly pull back on his throttle stick without realizing that the phenomenon of microburst is playing pranks on him. He quickly reduces power and then transits from that outflow to the left, then has a vertical one. I told you it's a 3-dimensional phenomenon that comes from the skies during thunderstorm. And then the one from top hits down on this aircraft,
pushes the aircraft,
and then a sink begins faster than necessary. The pilot quickly, again, pushes back his throttle stick to get power, and needs 6 light years to get a response from his...
6 seconds.
Yes, I call it 6 light years because those 6 seconds are too long to solve the situation on hand. But here is the one that drives the final nail to the coffin. As he gets over the vertical push, he now finds himself on the 3rd dimension. You know, I told you it's a 3-dimensional thing. He now finds himself on the 3rd dimension of the outflow to the right, for instance. As he crosses the one that pushes vertically and comes, this outflow forms itself into a tailwind and push this aircraft. What do you find? What do you find?
No, of course.
Bomb.
Knows that.
Right there, and a crash. 98% that is being the killer during either takeoff or landing. And that could have been what?
Now, from that clip that of course we saw, if the director can bring it back, now it looks visible.
No, because this is a schematic. No, this is a schematic view of to illustrate to you what exactly happens. It's not that it shows up like this in the air. No, you don't see it. You don't see it. This is just a schematic view to explain to you what happens.
Is there any dictator in place?
Oh yeah. That's an equipment they call low-level, wind shear equipment, which is called LLWAS. That is LLWAS. Low-level, wind shear. I'm trying to remember the something system. Okay. I'll get it to you in a short while. But the acronym is LLWAS. That I call it double L WAS. That's why I call it. We'll get there.
What does it do?
It's set up far away on the approach to a particular runway, and those are electronic, radio monitors, and some are set up close to the runway. The whole idea is that if they pick up signals on excessive wind speed and one appearing in those 3-dimensional thing, it sets off an alarm, which tells the pilot that, and this lasts for just a few minutes, usually. So it tells the pilot that wind shear or microburst is on. If pilots were to understand that they have, if
that instrument indicates that it's a microburst, or
yes.
Can it also, give the exact location of where it will take place?
Oh yes. It's usually the dangerous part of it is the one that is on the path of final approach. That is, if it happens elsewhere, it really does not bother the pilot. The one that is dangerous
that means if the aircraft has height advantage, it's not an issue.
It's not an issue, especially when it's on a high speed. It can just go through it, suffer some little turbulence, and pass through. The dangerous time is when the airplane is helpless and vulnerable, which is when it's taking off and it runs into a microburst. The likelihood is that it's going to come down. Or when it's coming in to land, low speed, usually 150, 160 knots, maximum depending on the weight of the aircraft, maximum, 170 knots. That is a very low speed. And of course the airplane has all its flaps deployed, to allow it, stay in the air at very low speed. And then suddenly something unexpected happens. Push up, push down, and of course it confuses the pilot. But if the pilot were to know that he has a microburst in place and he has passed his decision height, he's made up his mind that he's going to land, and then suddenly he finds that he's up against microburst. At that deceitful time that airspeed suddenly increases, the pilot will not reduce power. He will leave it there where it is.
Yeah, because he knows another one is coming to push it down.
That's correct. That's correct. Very correct. But it comes like a thief. It is really a thief. Very treacherous one. I mean, I'm talking about microbus and its associated wind shear. They are thieves. They sneak in without the pilot knowing exactly what's going on. Before he realizes he's up against microburst, an accident has already taken place. Let's do clip one quickly here and see how much of our clips we can run through so that our viewers, we have clip one, please. We've had an overview.
Yeah, but we should look at from the passenger's point what they should do whenever they are faced with that.
We discussed that last week, Joe. At all times when you're seated, have your safety strap buckled. Put it on. Just no point feeling too good and too comfortable, and when you're seated, you remove your safety strap. Know you that even the pilot flying you will not see this turbulence ahead of him. He will suddenly go into it, and if it's a terrible one that flips the aircraft up, down, sideways, and it's likely to haul you out of your seat and you break a bone or something.
Could I explain the reason why about 26 people got injured in the Paris?
Usually that's the case. Those that are properly strapped and braced usually are safe, even when there is a hard landing. For as long as there's no fire, those that are strapped and properly braced will usually come out unhurt. But those that are either loitering on the aisle or sitting without their safety strap, the likelihood is that the force is so awesome that you are like a fly. It hauls you out of your seat and banks you somewhere, break a bone or something, or your head. Some kind of thing can go wrong with you. So passengers must know at all times that you're seated in the aircraft, please have your safety strap on. So stop all these one that we'll call making guy.
Bro, I'm used to it. I've been flying, nothing will happen. Even when the plane is landing.
Very well. Please, let's run through our clips before we run out of time. Definition of wind shear. It's by the way, the word wind shear is some kind of general term for this phenomenon that we've just described. You have the other specifics like the microburst, the downdraft, and the rest of it. That vertical push is known as the downdraft. Known also as wind gradient. Wind shear is a difference in wind speed and or direction. Can you see that? Over a relatively short distance in the atmosphere. Atmospheric wind shear can be vertical or horizontal. Why vertical wind shear is a change in wind or direction with change in altitude. That's the vertical one. And then horizontal wind shear is a change in wind speed with change in lateral position for a given altitude. That's the difference between the vertical and horizontal wind shear. All right? Commonly observed near microbursts. Can you see that? And downbursts, which the downbursts are also known as downdraft. Okay? Right. Caused by thunderstorms, areas of higher low-level winds known as low-level jets, near mountains, etc. It has significant effects on control of an aircraft and has been a contributing cause of many aircraft accidents. Can you see that?
Okay, now can we take a look at that downburst? The downburst, a bit of explanation on that. The microburst.
No, I just told you that microburst is a three-dimensional phenomenon that comes during thunderstorm all the way from the skies. So the three dimension is one vertical, one outflow to the right, and one outflow to the left. And I already explained that to you.
That is what you also mean by downburst?
No, the downburst is the vertical one, Joe, the vertical one. Okay. The one that comes vertically.
Okay.
There are three dimensions.
It's
one, two, three.
All right, let's go.
All right. Spare clip 2, please. Right. 2, please. Definition of wind shear continues. In summary, wind shear refers to the variation of wind over either horizontal or vertical distances. Horizontal change in airspeed of between 30 to 45 knots, which is equivalent of about 15 meters per second or 22 meters per second, is usually regarded as significant wind shear by pilots. Vertical speed changes of more than 4.9 knots also qualify as a significant wind shear for aircraft. That photograph is what we have already dealt with, which is the three-dimensional nature of microburst.
Yes.
Wind shear is generic in nature. That is the word. The name rather, wind shear is generic, as against the specific ones that of microburst, downdraft, downburst, outflows. Those are specific names, but wind shear is general. Anytime there is a change in speed and sudden and unexpected change in speed and direction of wind, it is known as wind shear. But how it affects the aircraft,
and whenever that happens, it changes the movement of the aircraft.
Of course, it gives you
it can either increase the speed or reduce the speed.
As you transit from one to the other, coming from as you're approaching, coming from the headwind that it gives you, it comes down and spreads out, just like you're looking at it. Yes. Look at the aircraft approaching. That outflow in front of the aircraft gives it the headwind. The downburst in the middle gives it a vertical push from the top. As it crosses over, the other outflow gives you a tailwind and push you down and end of the story. Now go to clip 3, please. Why pilots dread wind shear, Joe? Low-level wind shear is capable of affecting aircraft airspeed during takeoff and landing in very dangerous ways. Pilots are therefore trained to avoid all microburst wind shear, which is equivalent to headwind loss in excess of 30 knots. Pilots' extra caution emanates from the following facts. Number 1, microburst intensity can double in a minute or less. Can you see that? Number 2, the wind can shift to excessive crosswind. You see, you're having a particular direction and suddenly it changes direction and changes speed and come back at you, as a crosswind. At a point that the aircraft is vulnerable because it's slow and getting ready to touch down.
I think we have explained that, right?
Yes. Then number 3, the crosswind mentioned in 2 above can be in excess of 40 to 50 knots, which is the threshold for survivability at some stages of low altitude operations. Now, but number 4, most historic air accidents associated with wind shear involve 35 to 45 knots microburst. Can you see that? Even though the threshold is 40 to 50 knots. Let's go to clip 4, please. Clip 4 very quickly. We continue with why pilots dread wind shear. Number 5. Wind shear is also known to be a key factor in the creation of severe thunderstorms and clear air turbulence, the one that pushed down this flight from Paris that hurt 26 people. All right. Number 6, the wind regime in a microburst is opposite to a tornado. Remember, tornado comes horizontally, pulling down everything on its path, while a microburst comes vertically from the top and spread out as that schematic diagram is showing you right now. My viewers, take a closer look at that diagram, pull them in, and then see the different parts of a microburst. So, number 6, the wind regime in a microburst is opposite to a tornado. It comes vertically down, hits the ground, and spreads outwards in all directions. A regime extremely incompatible with aircraft level flight. Number 5, clip 5, please, very quickly. Time is not our friend.
We have barely 3 minutes.
We'll probably do another one as part 2, because we have about 12 clips to go for viewers to appreciate this. But let's keep going. Wherever we stop,
for the program.
Yes, wherever we stop, we do the rest as part 2. Where and when can wind shear occur? Here are weather situations where wind shear can be observed. All right? When the temperature difference across the front is 5 degrees, 9 degrees Fahrenheit, or more, while the front is moving at 30 knots or faster. Because of time, I'm unable to explain some of these terminologies we're going through, but maybe next week when we're doing part 2, we'll be able to talk about them. Significant wind shear is usually observed as fronts are three-dimensional in nature. I already told you that. Frontal wind shear can be observed at any altitude between surface and the tropopause. I told you about tropopause last week. And therefore seen both horizontally and vertically. Due to their greater duration, vertical wind shear above warm fronts is more of an aviation concern than the near and behind cold fronts.
Now you can come back to us. No, we're already out of time. You can come back to us while we do, what do you call it now? As roundup. Do we have this system in our aviation sector?
Come again?
Do we have this detector you talked about?
We need to verify from from those that should know, NCAA and FAN, especially FAN, should be able to answer this question. And I expect that as I dole out this information, you don't expect those in the Ministry of Aviation who may be criticized or held responsible for not doing what they should do with our budgetary provisions annually. I'm not accusing them. I'm only saying that they shouldn't be the ones coming out to tell you, yes, we have them, or no, we don't have them. It's the job of investigative journalists. When you listen to programs like this and you get new pieces of information, you go to the appropriate agencies, confront them with the information you have. First of all, verify that whether this freak that is talking to the world, I am not just talking to ITV and Nigerians, I am up in the air, in YouTube, I am talking to the entire world, and I challenge anyone to come to me and say, you're talking nonsense. I challenge anyone, or even on the live TV, I can't be talking nonsense. I'm a freak of aviation, and aviation is another part of my life. And with all due humility, Joe, I know it inside out.
Amos, thank you for coming on the show this morning. Out. Thank you so much for coming on the show. Viewers, this is where we wrap up this discussion segment. It has been with the aviation freak, Mr. Goddy Ike, who also doubles as an estate surveyor and valuer. When we come next week, same time, we'll look at part 2 of wind shear. Now, take a quick break. When we return, the program this morning, ITV, continues.
June 19th, 1953. Julius and Ethel Rosenberg are executed in the electric chair.